Point P is midway between two long straight parallel wires that run north-south in a horizontal plane. The distance between the wires is 1.0 centimeters. Each wire carries a current of 1.0 amps towards the north. This question wants us to find the magnitude and direction of the magnetic field at point P. So, what we are given is the distance between the wire and the amps, which is 1.0 amps towards the north. Since the point P is midway between the wires, we'll be dividing that by 2. In order to find the magnitude, we'll need a component for the equation, which is the magnetic field from a long straight wire equation. This will give us the magnetic field. In the equation, the components are following: the permeability of free space, which is equal to the 4 pi times 10 to the negative 7 newtons divided by amperes squared. We also have the current, which is 1.0 amps, and the distance. Since I mentioned before, this problem, we want us to divide it by 2 since we have the point P midway between. Plugging this into the equation, we receive 4 times 10 to the negative 5 Tesla, which is equal to 40 microtesla. Now we're going to need to utilize the right-hand rule to determine the direction of the magnetic field. For the left part of the wire, the field at point P is into the page. It's also important to note that when you're using your thumb, that is the direction of the current. Regardless, the right wire at field at point P is out of the page. Another important part of this equation is that the lines are perpendicular to the line connecting the wires. This will form a field that will point diagonally upward, and the vector will form at 45 degrees. Now that we have both the components, we can utilize these components to calculate the magnitude. So for the horizontal component, it equals bx equals b cosine of 45, and for the vertical component, by equals b sine of 45. For this equation, we'll be using b as a magnetic field as well. Plugging in the values, we get 2 times 4 times 10 to the negative 5 times 1 divided by square root of 2, which is a trigonometric function. Regardless, this will equal to 2.83 to 10 to the negative 5 Tesla. This is the magnitude for the equation, and the direction for the magnetic field is 45 degrees out of the plane.